Well, hello there. Mr. Bucko here with problems number 18, 19, 20, 21, and 22 from the Chapter 6 review in the geometry book, where these all deal with inscribed angles and intercepted arcs and things like that. So we're going to review this a little bit. So I have 18 to 20 on the screen right now, which pertain to the figure that we see here. And it says to use the figure. We know that O is the center of the circle, and we're going to calculate each of the angle measures that we are asked. And first we're asked to find the measure of DCB, which is this angle right here. DCB is this angle, and if you're not sure exactly what that is, it's this angle right here. See that little marking? We want to find out how big that angle is. And this angle is an inscribed angle because the vertex of this angle is on the circle, and the two sides of the angle intercept the circle at other points. So we have to find out how big this is, and we have some information that we're going to use to find that. So I notice that with this angle DCB intercepts this arc right here. From D to A to B, this arc is intercepted by the angle that we're looking for. So if I knew this arc, then I could find this angle because there's a relationship between the intercepted arc and the angle which intercepts it. So if I look at this, not sure how long that is, it doesn't tell us, but I do see another angle that intercepts this arc, and that's this angle DOB. DOB also intercepts the arc DAB, and I do know how big angle DOB is. So there's the orange line there is the intercepted arc. That's what I'm kind of looking for. Because if I knew what this was, I could find out what the angle measure is, because there's a relationship there, which we'll talk about in just a second. But I notice also that DOB intercepts this orange arc also. And this measure, angle measure right here, is 43 degrees plus 49 degrees. So this is a 92 degree angle right here. This red one is 92 degrees, and it's a central angle. And the central angle of a circle, meaning that its vertex is in the center, because O is the center, is the same measure as the intercepted arc. So if this is 92 degrees, then arc DAB must also be 92 degrees. And this 92 comes from the 43 plus 49, because again, the intercepted arc is the same measure as the central angle. Central angle right here and inscribed angles, two very different things, and they have different relationships with the arcs that they intercept. They both intercept the same arc, but the inscribed angle, this angle right here, which we are looking for, is half the measure of the intercepted arc. So here's the intercepted arc, 92, so therefore this angle must be half of this arc. Half of 92 is 46. So therefore, angle DOC right here has got to be 46 degrees because 46 is half of 92. Now we have to find angle DAB. DAB is this angle right here. So this angle right here is what we're looking for at this point. And that's another inscribed angle because the vertex is on the circle. So if I knew the measure of this arc right here, I could find the measure of that inscribed angle. And it looks like I don't know any of these arcs at all. But I do know that this angle right here, BOC, which is a central angle, is 139 degrees. So if this angle is 139 degrees and it's a central angle, its intercepted arc is going to be the same measure. So that BOC angle intercepts this arc, and this arc must also be 139 degrees because the central angle which intercepts it is 139 degrees. So now I have this accounted for. So I have 92 accounted for, 139 accounted for. Now I need to know this. And I can find this because I know how many degrees are in a circle, 360. I have 92 and 139 already accounted for. So if I can find this measure, this arc, which I can because I can do 360 minus 139 minus 92 and get 129. So this arc right here is 129 degrees. And this arc, the dark red arc, along with the black arc, is the intercepted arc of angle DAB. And the relationship between the intercepted arc and its inscribed angle is that the arc is twice the measure of the inscribed angle. So that the intercepted arc here is 139 plus 129, which is 268. So the black arc plus the dark red arc is 268. Therefore, the inscribed angle is going to be 134 degrees, because 134 is half of the dark red arc plus the black arc, which is 268 degrees. So angle DAB right here is going to be 134 degrees. Lastly, we have to find angle BDC. BDC. So we have to find this angle measure right here. Well, this angle measure, this inscribed angle, opens up and intercepts the arc 139. BDC, right here, this angle intercepts this dark black arc, or the black arc. And again, the relationship between the intercepted arc and its inscribed angle is that the intercepted arc is twice the inscribed angle, and twice of 139 is 169.5 degrees. So BDC is 69.5 degrees. Moving on to 21 and 22, another figure here where we know that measure of angle ROH is 54, so I'll plug that in right now. That's 54 degrees. I know that because we're told that. We have to find these other angle measures. HGR, so we have to find this central angle here. And I'll notice again that angle H, or ROH, intercepts the same arc that HGR does. And I know this measure right here is 54, so that means that this arc right here from H to R has got to be 108 degrees, because this is twice that angle measure. And this is a central angle. That same central angle also intercepts that arc, so HGR must be 108 degrees. So HGR is 108 degrees. Now I have to find ORU. ORU. So that's this arc right here is intercepted by this angle. So if I knew this angle, I could find the arc. If I knew this arc, I could find the angle. Have some information here. I know that this is 108 degrees. Therefore, this angle over here must also be 108 degrees, because these two are vertical angles. This central angle then is 108 degrees. So therefore, this arc that it intercepts must also be 108 degrees. Here's the inscribed angle of that same arc that is 108 degrees. So therefore, ORU must be half of 108, which is going to be 54.